During catalysis-related research, data in various formats is produced, including raw experimental data, characterization data, synthesis data, publications, reports, scripts, and more. There are multiple ways to save this data, such as pen and paper, USB sticks, local computers, databases, repositories, and clouds. However, in research, our goal is to achieve sharing and reuse of data and results. For this purpose, centralized approaches or software that provide access for multiple users are preferred. Databases and repositories are such systems that can be used for research data management. Let's take a closer look at databases and understand how they work. Databases provide the ability to save information and data in a structured way, enabling efficient searching and management of stored data. There are different types of databases, including relational, non-relational, object-oriented databases, distributed databases, and graph databases. The most common database types model tables with columns and rows that contain the data and can have relations to each other. However, most databases face limitations when dealing with a mix of diverse types, inconsistent or detailed data, and complex relations. In research, we not only want to store the data, but also share it, preserve it, and archive it, and provide the ability to reuse it for further research. This is where repositories come into play, offering more useful functionalities to support research data management. Repositories are a software infrastructure that includes multiple databases for storing and preserving data and results of all types of formats. Similar to databases, this data is stored in a structured way, enabling efficient searching and management. There are different solutions providing different functionalities, such as software repositories. Some of the functionalities offered by repositories include the ability to provide metadata, define metadata fields and standards, versioning, user and permission management, publishing and sharing data using DOIs or PIDs, and APIs to utilize the data or provide additional functionality. Within research, finding the best solution for your purpose depends on the required functionality, such as advanced permission and user management, which is crucial for catalysis-related sciences. Additionally, the ability to add additional functionality and the legal framework in which the repository is intended to be used are important factors to consider. To enable the full research data lifecycle using repositories, the deposited data should follow metadata standards, provide sufficient metadata to describe the data through annotation, and use controlled or defined terms and vocabularies. In short, it should follow the FAIR principles. Repositories enable research data management following the FAIR principles, which improves cooperation and exchange, ultimately enabling further development and innovation within catalysis-related science. Find more useful information on how we can help you or your organization, or support us. Ask us questions or simply subscribe to our newsletter to stay in touch. Join us in shaping the data-driven evolution of catalysis. nfdi4cat.org